Uh, Good morning. Thank you, Mr. Wong, Mr. Luo, Sidikaye, and all of you here for the opportunity to present. I'm Rob Whitlock from KPF. I'm joined by my colleague Lile. We've been working on this project. We're honored to have been working on this project for the last 7 years. And I'd like to give you a little bit of insight into the design process. This is, the focus of this discussion is about the integrated design process, and I can't think of a project that is more exemplary of that approach. The tower itself is really quite unique. It's, as you can imagine, is the tallest building at the center of Beijing. It's almost the tallest building in China because of its formal and cultural significance. So this building, this design has received an enormous amount of scrutiny every step along the way. It's been essential that we come up, it's a project that is integrated in design. It takes the forces of the program, the structure of the engineering, a very tight time schedule, a broader city master plan, wraps it all up into one project. It's a building that's sited above public transportation, so really is a paradigm of what we think of as the highest and best example of super high-rise construction. One of the great challenges in taking this North American building type and applying it to China is to figure out how we find some sort of cultural relevance, how we take a building that is essentially looking towards the future simply by definition, but find a way to tie it into China's history, culture, and persona. The Zun, the traditional communal drinking vessel, was initiated as that concept. It was introduced by BIAD and Terry Farrell in 2010 during the land bid competition phase. And you can imagine that that concept really resonated with the jury, with the mayor, city officials as sort of a new way of thinking about how you take a single commercial building and somehow make it representative of a larger culture. We took that concept, a building that has a narrower waist than base and a top, and that was the genesis for our design process, which has enveloped or proceeded since 2011. That form, it seems like a simple process, but you know, a building is a very solid monolithic thing, and our sort of intellectual conceit initially was, instead of thinking of it as solid, to think of the curtain wall as this malleable shell. And if you think about most, whether it's a low-rise traditional building or the Empire State Building in New York, the most successful buildings are ones that somehow deform at the public scale, at the street level, to welcome people in. They have some profile on the skyline that gives them some resonance, some memorability, and then the tower form stretches in between. So at the base of the tower, rather than having this 528-meter building come crashing to the ground with a little canopy and entry doors, we chose to take the curtain wall and flare it out, so the building is almost welcoming you in. This is for a building of this size, this is an absolutely tiny site. So this entry canopy is almost at the street. There's clearly vehicular drop-off, but this is a way to say, this is a building that is for the entire city, not just the residents or occupants of that. And at the top of the building, the lantern, the observation deck, is sort of a way of giving the building back to the public, and the profile on the skyline is one that starts to take on some more lyrical character rather than just the flat top of a modern building. So we started with an idea that the building had a waist, met the ground solidly, had a flat top. We've transformed it into something that really resonates and creates a building that we think is even more suitable for its location. Those same moves helped us think about the way the inside of the building worked, not just the sort of formality of this surface structure. That canopy that comes out at the base allowed us an opportunity to almost dematerialize the entry wall. We have a point support cable glass wall, and that allows you to see deep into the lobby from out on the sidewalk. The building form presents the drop-off canopy, shelter for entry, and you have this building that really opens itself up. And then at the top, the core as it rises is sort of almost more literally the cylindrical zone form. The structure transforms itself to steel. The intermediate mullions drop out, so you get great visual connectivity from inside to out. And on the skyline, that observation deck also becomes a lantern. And I think you can see in this image, there's also, for a building it's as tall as it is, I think there's still a way that you find some way to create dialogues with surrounding tall buildings. And you can see with the two buildings on the right-hand side, the way they recede to the top, they're almost nested together and find it's almost like Fred Astaire and Ginger Rogers dancing together. They have some synergy on the skyline. But this is really a sort of parametric design process about how you take this sort of preordained idea about a building with waste and have it meet the interior programmatic conditions. When we started the design, the brief was office, hotel, service apartment, and observation deck. Over time, as CITIC thought more about the operation of the building, realized that this was an opportunity to bring all of their employees into one place instead of being scattered around the city. We went to a single-use approach. But with each of these moves, we kind of had to completely rethink the building. A high-rise building, simply extruded, is I guess maybe in some ways you could think of it as efficient because the exterior envelope is repetitive, but it would be entirely wasteful because you know that a building of this height is really about the design of the core. As Mr. Shao, in his really wonderful presentation, conveyed there are 101 elevators. So the core at the base of the building is enormous, and at the top of the building it recedes. So if every floor plate is the same size, you don't have enough leasable depth at the bottom, and you have way too much at the top with depths that are greater than you need. So our design process was one of almost designing from the inside out. The core, as it developed with the appropriate core to perimeter dimensions required for leasing at all those forms, started to push at the outside of the building to help determine the final form. This is also about structural efficiency. You know that most buildings of this height utilize a mega column system, 2 per 4 facade. Each of the 4 facades are like IFC or ICC in Hong Kong. Those columns run vertically over the height of the building. It's really quite repetitive, but the other thing that you probably know about this project, it's in the worst seismic zone in the world. So it's almost like liquid soil. So we take the opportunity, the building as it tapers goes from roughly 56 meters at its waist to over 70 meters at the base. So the structure can perform almost like the Eiffel Tower, where those 8 columns start to almost merge together at the corners to give really great structural stability and with that great efficiency. I think Luping will talk about the structure a little more, but the design of a high-rise building is also about a form that behaves in a good way in the wind. So the curves of the corners, this aerodynamic form helps minimize vortex shedding, helps reduce the amount of structure required to provide a comfortable working environment. So all of these moves of structure and core had telegraphed themselves through to the outside of the building. You can also imagine we have a fixed height, we have a fixed amount of GFA. Every time the perimeter of the building moves, the GFA has to be balanced. So this was a constant process of really right-sizing the building, coming up with a form that was acceptable to the mayor, the planners, and sort of work together. There have been a number of comments that the building doesn't really have to look beautiful, it just has to work very well. But as the tallest building in Beijing, it was important to very many people that this be an elegant form on the skyline. We spent a lot of time thinking about the position of the building on the skyline, the buildings that surround it, and the visual context that's created. And so where the waste of the building occurred, how the taper occurred, was took an enormous amount of effort to get consensus, both visually and at the same time allowing the building to work well internally. This, of course, has to be then realized for construction, and we went through a rationalization process to help make sure that all of the surfaces were easily subdividable and constructible. Part of that, so how do we think about this building that's curving in essentially all directions, how do we rationalize it? What we chose to do was treat the corner as a constant radius throughout the majority of the height of the building, with the 4 intervening surfaces as simply subdivided ones. We chose to increase the radius at both the top and the bottom of the building to help define the form and work with some interior planning measures. The design of the curtain wall adopted a vertical striation that seemed to us to help accentuate the flare of the building. It also helped us rationalize the building to be constructed. The interesting thing when you start to say, well, the building is a zone, as you know more than I do, there are many, many zones. And we looked at the more orthogonal version on the right with its ribbing and thought that was a good starting point for the surface rationalization. Here you see the building as it's nearly complete with those fins. There's it's essentially a 1.5 meter planning module with a major fin at every other location. Those are profiled to catch light. They've also, as Mr. Shao pointed out, have got to accommodate window washing, exterior illumination. But we wanted this building not just to be a glass building, but to have a sense of depth, a sense of richness, a sense of texture. The process of trying to figure out how to rationalize this, the building has over 25,000 pieces of glass. And the simplest way to subdivide the surface of the tower in a way that created the least variation was to take each floor of its varying sizes and subdivide it the same number of times. That means that you have a different glass panel size on every floor, but on that floor all of them are the same size. We've chosen through the vertical expression, to vary the width of the vertical mullion so it's much wider at the base. There's really a proportional relationship about the amount of solidity to the overall surface area of the building, so that it sort of feels, you get a sense of movement. It's a dynamic expression, but it's also one that you'll see in a moment allows us ways to further rationalize the scheme. Because of this idea of subdividing an equal number of times, in the middle of the building, the mullions are vertical, but to the top and bottom, as you move away from the center points of each facade, the mullions start to slope. And because we chose this system of an additive mullion on top of the glazing, we could regularize the glass underneath so that they're actually vertical panels rather than all being trapezoidal. With the mullion cap going over it, you don't see that from the outside, but it's a way within a unitized system to really vastly simplify both the shape of the glass and the number of different sizes. So this is essential if we're trying to achieve both economy and speed in production. So all of this thinking enabled Zhonghe in their production to move much faster than they could have otherwise. Again, the simple rectangular panels in the middle, and then this transformation over the height of the building. At the base, we did require buildings with glass pieces with greater variation in order to allow the form to be met. The idea of taking the surface area and creating a canopy is, I think, a real breakthrough for the building, but it also created some engineering challenges. As we take each of those center lines, each of those is defined by a simple radius. So each of those sections is a regular one, and the transformation or deformation occurs in between those two. Here you'll see under construction, the steel ribs, which were fabricated from our 3D models, start to come out and form that canopy. And here is the final design, that transformation occurring at the base. For building this curving in two directions, we're essentially able to eliminate warping glass throughout the building. As we start to twist at the base, we did resort to this shingle system to allow planar surfaces to still be used, and I think it actually provides a great richness at the base. Here you see the ribs coming inside, so the exterior expression actually carries to the inside of the tower. so that they really are united. And here is the interior rendering with the core wall created by a series of extruded aluminum pieces that have the same plan profile as the tower, and they radiate and come to meet the curtain wall on the exterior. I hope some of you have a chance to tour the building this afternoon. The image on the right is from the visual mock-up, full-size mock-up created during the construction process to refine the details. At the top of the building, the same transformation occurs. Here we go to a steel structure. This is actually hung from the structure above to deal with the structural movement, and we have point-supported glass wall that stretches in between. And there, the lantern on the skyline. This design process is one that utilized a number of digital tools. We designed the model or the building in Rhino. We used Grasshopper to parametricize the movement, so as we adjusted area, the spacings work. So this is a sort of a process that is constantly self-informing, and the output allowed us to generate drawings for both curtain wall production and slab edge definition, etc. These are a lot of very fancy drawings that just talk about a very involved process that really helped us take a building of great variation and standardize it in a way that construction could occur efficiently. Again, we used this to make sure that we had a system that could be constructed economically and was taken all the way through every aspect of the tower. I think we really I would like to credit Sidikaye and Mr. Wong for the leadership in the design process. I think I'm speaking for the entire design team. This has been almost a once-in-a-lifetime experience to work on a project that is so integrated, is so clearly thought through, and is, I think, going to represent or be a great iconic building on Beijing's skyline, one that will do credit to the city, to China, and certainly be a model for others to emulate as they think about how to design super tall buildings on city skylines around the world. Thank you.